Topic 5, water quality. Environmental monitoring is also called biological monitoring. In this, we're monitoring the quality of an environment. So we're looking for non-persistent pollutants and persistent pollutants. A non-persistent pollutant can be broken down into simple non-polluting compounds by naturally occurring chemical reactions or bacteria. So for instance, newer pesticides are non-persistent, unlike DDT, sewage, and fertilizers. Persistent pollutants accumulate in the environment, break down very slowly or not at all. Damage can be irreversible. For instance, DDT we've looked at. Petroleum products and heavy metals take a long time, if ever, to break down. The water cycle is heavily impacted by this because most pollutants end up in a water supply due to the water cycle and then end up being studied there. Any chemical in a high enough concentration can cause harm to an ecosystem. Water clarity could be an indicator of water quality, but clear water does not indicate what chemicals are present. Water quality is determined using both chemical and biological indicators, depending on what the water is going to be used for. Biological indicators are species that live in that environment. So when there's good water quality, we have a high dissolved oxygen level. A good water quality, there's signs that it's good in that there are fish and frogs, macro invertebrates, which are organisms visible to the naked eye and lack a backbone, like the stonefly, mayfly, caddisfly. And their survival is linked to the presence of pollutants and pH level. So they can't live in a pH below 5. Therefore, none of these will be there if there's less than 5 pH. And they have to have a high amount of dissolved oxygen, otherwise they also don't live there very comfortably. They'll die off. Something that has a poor water quality or low dissolved oxygen level doesn't mean that there's nothing living there. It just means that there are different organisms there that don't need a lot of oxygen. So midge larvae, leeches, snails, worms, they thrive in polluted water as they require only small amounts of dissolved oxygen for survival, as well as carp or catfish, kind of like what people would refer to as bottom dwellers. They don't need a lot of oxygen to thrive. So poor water quality would have these guys. High water quality or high dissolved oxygen would be these guys. Macroinvertebrates, again, are organisms that are visible to the unaided eye and lack a backbone. They occur in lakes, rivers, creeks. They are the focus of many water studies. So the number of them found and the different types of them found in water can be an indicator of pollutants. So we see in this river or something that has a direction of flow, so the water is moving this way, we have a clean zone and there's lots of dissolved oxygen. So we have all of the things that we were looking at in a high oxygen level. In a decomposition zone, you can see that there is some sewage coming into the water here. We end up with carp, catfish, some leeches, and we see the dissolved oxygen level go down quite low. In this low zone, we're finding not even fish. We're really just finding the worms, midge larvae, and mosquito larvae growing there. In a recovery zone, so over time, oxygen can be reintroduced to a lake, and we'll see some of those fish come back, those carp, catfish, etc. And as they do so, they'll bring up the oxygen level over time again, and we can have all of our fish return to this area. One of the big ways that dissolved oxygen can increase would be the temperature of the water. Cold water is able to have a higher dissolved oxygen level than warm water. This is because gas molecules move and they escape warm water easier and they're held in colder water easier. Think about a bottle of pop like that, dissolved gases. Additionally, dissolved oxygen increases when there's water flow. So moving over like a stream would carry more oxygen than maybe a lake. A lake is still moving. It's just harder to see. So movement of water and temperature are really big on changing dissolved oxygen levels. Chemical indicators of water quality. So we've looked at biological. Chemical tests for water quality can include tests for phosphates, nitrates, biological oxygens, pH, turbidity, which is how well you can see through, heavy metals, pesticides, and salts. So phosphates and nitrates in a water supply. In clean water, the phosphates, we have a low concentration of those. And nitrogen or nitrates, we also have a fairly low concentration of those guys. In polluted water, we have a high nitrate and phosphate concentration, as well as increased carbon dioxide, decreased oxygen. Excessive amounts of nitrates and phosphates in water is a sign of decomposition of organic matter. So dead or fallen trees, maybe runoff from a field of cattle. Algae is a clue to increased phosphates and nitrates. So when we have increased phosphates and nitrates, we may get increased algae. Typically, this comes from fertilizer runoff or dead organic matter being added to the water, and we're going to get an algal bloom. This can cause oxygen to be depleted in the water, killing fish and other organisms. And so we see kind of that green pond scum on top. That is an algal bloom. So eutrophication is a nutrient pollution. Humans add nutrients like phosphates, nitrogen, and carbon to streams and lakes, typically from fields, fertilizers, field lots, urban settings, golf courses, etc. Untreated or partially treated domestic sewage is another major source of this pollution. Again, this causes an increase in plant growth, like an algal bloom. When plants decompose, they consume oxygen, and microorganisms need that oxygen in order to decompose plants and animals. So we're using up the oxygen in that water system. This leads to animals and fish dying, again, causing a low oxygen water system. Looking at pollutants entering a system, a point source pollutant is one where we can actually locate. We can measure how much pollution enters an ecosystem from that source. Okay, so they are easy to monitor and control, like smokestacks, drain pipes. We can actually physically measure things. A non-point source pollutant is often separated both in time and location from the source. They cannot be easily monitored or controlled, and they occur as a result of runoff or leaching, and they quickly get dispersed. These could be things like feedlots, the runoff from a feedlot you can't actually measure, golf courses, the emissions from cars, or fertilized fields. Don't forget to complete the learning guide for topic 5, and there's some extra practice on page 235. Number 3 and 4 are ones I would recommend.